seen before about limits of functions. In this lesson, we are going to look at one-sided limits. At the end of the lesson, you should be able to state the difference between a one-sided limit and the limit of a function. We have talked about the limit before. And after you see one-sided limit, you should be able to state the difference between the one-sided limit and the limit of a function. Okay, before we get into that, let's look at the piecewise function. So let's say I have a function that yx, let's say on the negative x-axis, on the negative side of x, that's on the left side of y, the function is defined as, let's say on the negative side you have the function is defined as y equals x squared plus 2, for example. So it means your function should look something like this. This is x squared plus 2. But now I only want the negative side. I only want the negative side. Let's say the function when x is equal to 0 is not there. This is the point 2, for instance. And then let's say from the right side of the x-axis, the function is negative 3. So I have a dot here, meaning that the function when x is equal to 0 is negative 3. And then let it continue like that. Y equal negative 3 on the right side. This function, we can write it as, we can write this function as f of x equal x squared plus 2 when x is strictly less than 0, and f of x equal negative 3 when x is greater than or equal to 0. Remember, when we have greater than or equal to, it means the function does exist at the point 0, and when it does exist, you have a solid circle. And this one, when it's strictly less than, you have an open circle at that point, or strictly greater than, you also have an open circle at that point. If a function does not exist at a point, you have an open circle as well. Okay, let's consider this function defined piecewise. Can we write down the piecewise function? Certainly. We find here that when x is less than 3, on the left side of 3, our function is 3 as well. So write f of x is equal to 3 when x is less than 3, strictly less than, because you have an open dot there. At the point 3, you see there is there's this solid dot. So it means, and that is 1. So f of x is 1 when x is equal to 3. And finally, there's another open dot here, and this value is negative 2. So f of x is negative 2 when x is greater than 3. So, from here, what is f of 0? F of 0 is on the negative side of 3, so we will use this function. So f of 0 is 3. What is f of 3 is what? When x is 3, f of x is 1. So f of 3 is this one here. F of 3 is 1. And f of, say, f of anything greater than 3, say f of 6 is negative 2. What about the limit as x approaches 3 of f of x? The limit as x approaches 3 of f of x, we have to investigate from the left side. As x is approaching 3 from the left side, f of x is approaching 3. And when x is approaching 3 from the right side, f of x is approaching negative 2. So because the left side and the right side limit is not the same, it means this limit does not exist. Does not exist. However, we can say that the limit as x approaches 3 from the left side, we will put minus over 3 of f of x. From the left side, it is this 3. It is 3. And from the right side, the limit as x approaches 3 from the right side we use positive above 3. As x approaches 3 from the right side of f of x is what you have here, is negative 2. So this is called the left hand limit of f of x, and this one is called the right hand limit of f of x. So we say that the limit of f of x will not exist if the left hand limit and the right hand limit are not the same. If the left hand limit and the right hand limit are the same, then the limit of f of x will exist. So we can say that the limit as x approaches a from the left side of f of x equal L, and we read it as the left hand limit of f of x as x approaches a, or the limit as of f of x as x approaches a from the left is equal to L if we can make x, if f of x gets arbitrarily close to L when x is sufficiently close to a and x is less than a from the left side. Remember, like I just said just now, the limit as x approaches a of f of x equal L if and only if if and only if the limit from the left side is L and the limit from the right side is also L. The limit as x approaches a of f of x is L if and only if the limit from the left side is L and the limit from the right side is also L. Okay, practice exercise. From this piecewise function, we can evaluate the limit as t approaches -4 from the left side. This is -4. From the left side, it will approach 1, 2, 3, 4, 5. This is 5. So from the left side is 5. From the right side, it is 2. 2. And because the limit from the left side and from the right side are not the same, this limit does not exist. How about g of 4? G of 4 in this case, you are looking for, it exists here, but it doesn't exist there. So g of 4 is 2. 2. Okay, how about this one? For this one, you can see that f of -1, for example, is 1. F of 1, for example, is 1, because it's this one, not that one. F of 2 is what is this dot here. So f of 2 is 2. And f of 3 is 1. Also, you should be able to evaluate limits here. The limit as x approaches, the limit as x approaches 1. The limit as x approaches 1 from the left side of f of x is what? From the left side, it is approaching 2. That limit is 2. But the limit as x approaches 1 from the right side is this one, which is 1. That limit is 1. So we can say that the limit as x approaches 1 of f of x does not exist. Oh, sorry, I forgot to put f of x here. How about this problem? What is the limit as x approaches 2 from the left side of g of x? From the left side, the function is approaching 3. So this is 3. From the right side, the function is approaching 1. So this is 1. This one does not exist because from the left side and from the right side it's not the same, so it does not exist. The limit as x approaches 5 from the left side of f of x is 2. The limit as x approaches 5 from the right side of f of x is 2, because the limit from the left side and the right side is the same. The limit as x approaches 5 of g of x exists, and that value is 2. But g of 5, here g of 5 is this dot. The function does not exist at this point. So g of 5 is 1. Okay. There is the textbook page. Download below this video. Download it and solve exercise 43 to 60 to practice. Thank you.